Um, well, welcome everybody. Thanks for taking time to chat with us today about Docker Hardened Images, supply chain security, and the role it's playing in AI. We're going to get into this. And first off, some housekeeping items. Sessions are being recorded. It will be shared afterwards for rewatching later and sharing out. You'll see polls, you'll see some polls pop up, but you'll also see an option to do Q&A. So you can submit your questions throughout the talk, and then towards the end, we will leave plenty of time to go through as many questions as we possibly can. We'll get through it, we'll get through as many as we can. You'll also be able to upvote the questions that were previously asked, and we're going to try to get to the ones that are most popular. And then there will be another poll. So thank you for filling out the poll now. A little survey will also come out at the end. Always looking for feedback and how to make these webinars most valuable for everybody. All right, so with that, we're going to get into it. I'm going to let my co-host introduce himself first. CD, are you there?
I sure am. Hey, Mike. Hello everyone. Christian here. I'm based in Germany. I'm working with Mike on all things security at Docker across Docker Hub, our AI MCP tools, and most recently DHI, Docker Hardened Images, which is what we're going to be talking to you today.
Thanks,
Over to you,
CD.
Mike.
Yeah, unfortunately, neither of us are riding our bike right now, but it's okay. I'm Mike Donovan. I'm the Vice President of Product Management here at Docker. Working really closely with CD on all things supply chain security, and really excited with the announcements we've made and continue to make in this area for the ecosystem overall. So before, to set some context, I think it's always important before we get into a lot of what we're here is to set context around the problems that we're trying to solve. I think these two graphs just really summarize the problems really well. On the left, you see the massive spike in adoption of open source software, right? That's not news to anybody. I think it's always heartening to see the massive rise though, and this has led to a ton of innovation in the market, right? This is the graph is essentially download rates across all the different ecosystems, all the different open source ecosystems, including the Docker ecosystem, and just seeing a massive spike in adoption of open source that continues, right? It's something we all use every day. That's led to a ton of innovation and essentially being able to build our software on the shoulders of giants. It also means that most software that we write today is not composed of software that most applications that are built are mostly composed of software that we didn't write, right? Open source software that we include as dependencies. On the right, though, is the sort of the problem related to all that open source software, and that is the even greater rise in CVEs and vulnerabilities associated with that open source software, and that has been rising at an even higher clip than the adoption rate of open source software. I think essentially represents the risk that we all have to manage and deal with while we use open source software. It's something that just creates massive risk for our applications, for our organizations, that all of us essentially have to deal with as in some form or fashion. And of course, we're here. We don't want to. This is the current state, but we're not sitting idle. We're trying to do something about this because open source is so important for the future of software, especially the age of in the age of AI and the age of agentic development. Because it's not necessarily slowing down the risk, right? So when we look at the rise of agents, whether it's coding agents or whether it's just the use of AI, it's really the rise in more autonomous and even non-deterministic systems. And so all the same that exposure to vulnerabilities and malware from dependencies that you pull into your supply chain, we think the risk is just amplified even more so, especially when you have coding agents making decisions on essentially your behalf about which dependencies to pull in, new attack vectors that are being introduced, whether that's like prompt injection or others, or whether that might be even with the use of different tools that you give your agents. So when we think about the rise of MCP servers, it really they look like a lot of other supply chain codes. And we look at attacks that maybe have happened. They look a lot like other supply chain attacks that we've seen in the industry for a long time. But the issue is just the amplification of the risk because agents and AI are making decisions, are doing things autonomously more and more so as we all become much more comfortable with coding agents and the like. Um, and so, whether this be using the use of Claude Code, whether it be Cursor or other ones, whether it's using the Docker AI, it's all things that we need to really take seriously the supply chain security risk that's amplified with AI and agent workloads. Now, I know that might seem a little scary, but I think what's actually something that we find a lot of comfort in at Docker is that it's a lot of the same problems, just a lot of the same root problems at least, just coming out in a new way, right? And so why that's why we feel why that's good to understand is because we know how to solve a lot of these problems. A lot of these problems look like the same supply chain vulnerabilities or attacks that have been in the industry for a while, and it's things that we've been on a journey to solve for a while. So a lot of the same, by understanding the same sort of core foundational tactics to counter, to remediate these kind of issues, to manage the risk essentially, you're able to then also manage the risk for agents and AI workloads. So whether that be isolation, right, essentially limiting the blast radius, why we all use containers every day, frankly. Um, the art of minimal only running as little software as possible, so reducing the attack surface through only running the absolutely necessary components. Um, Whether it's being able to prove where things are coming from, make sure you understand the provenance and the source of your actual software, open source software that you're allowing into your supply chain, and then managing your vulnerability, your security posture in a transparent way, right? We very much are big believers in the use of SBOMs and VEX and other standards that really just raise the overall level of transparency that you're managing your security posture with. This is the foundation of container security, and we think it's also the foundation of AI security. Docker's had a front row seat to this whole to open the open source industry. Of course, the container ecosystem, but even the open source industry overall, just because a lot of the ways that developers and engineering organizations get access to open source software is through container workloads, right? It's through images that they're getting from various registries, Docker Hub being one of them. So we're stewards of a lot of the way of the container ecosystem and a lot of the ways that developers get access to open source software. And our role is continue. It doesn't stop. It's only increasing as MCP servers are now an increasing amount of open source software that people are downloading as agents and different components that are being used to build AI workloads are open source. We're continuing that stewardship into the AI era. So the stats of the container ecosystem are always impressive, just with the sheer number of developers we help, the sheer number of downloads of open source software, and the sheer number of containerization that happens both in the microservice and DevOps world and cloud native world, but also now in the agentic workload world. So we take our role here very seriously to help make sure that this ecosystem is one that leads to a ton of innovation, but doing so safely. And this is, we're going to go into a lot more about Docker hardened images and what that is, and what problems we're solving, and the recent announcements about making Docker hardened images the standard for the industry, frankly. But this is meant to be that new secure foundation for how you use containers and how you allow open source software into your supply chains, whether that be for the hardened base images and applications and like just fully deployable applications like databases, orchestration tools, making that be the standard for those, making hardened images the way that you use and deploy MCP servers, because An increasing amount of MCP servers are now being deployed as container images because of all those the isolation properties and others. Whether that be deploying Kubernetes workloads and the Helm charts that are available in the Hardened Images catalog, or whether it's the supporting components around AI and ML type of applications that you might be building for training, for inference, or for anything else. Our goal is to provide you that catalog of open source software essentially that you know you can trust and build with. I'm going to hand it over to CD to talk about really the impact of hardened images.
Yeah, thanks, Mike. I've been following the questions in chat and Q&A already a little bit, and what people are asking is why do we need all this? Like, why do we need Docker and to help us fix CVEs and provide these hardened images? Well, there's a little bit of this on this slide here. It looks very dramatic, but it's actually very simple. Like on the left, you'll see all the things that you need to care about as you build applications, not just images, but just starting with consuming open source packages. Like where are these things coming from a compliance perspective? How do you get them released, tested, and validated? Then your security team comes in. You have to build them, track provenance, and all this stuff. And um, when you actually go in and track upstream updates and want to rebuild when these things happen, it gets really, really hard. And then as you move to the right, there are all these different variations of things, different image types. So we're talking about base images, applications, variants, like you may be using different operating systems for different types of applications, Alpine, Debian. We're thinking about different variations of is something for production or is something a built environment, different architecture. So that's kind of just the first box, and you can already see how this is kind of like creating you a product of products here that makes this problem really, really hard. Version and lifecycle, I think we touched on this a little bit, like every open source component in the upstream is constantly updated. How do you make sure that you incorporate these images, these updates into your applications and into your base images? How do you track EOL software that has reached end of life? Maybe potentially backport a fix and all these things. And then over time, when you have just this portion sorted out, how to keep your application up to date at all times, there is this really weird Friday evening coming where the next person discloses a CVE unresponsibly, perhaps, that you suddenly need to scramble to get into all of your applications. So you go back and kind of do this whole thing again across all your applications, all your dependencies, all your images, all your environments. And then at the very end, you also need to worry about compliance, SOC 2, FIPS, and STIC, and all these things. So you can see how this gets harder and harder and harder and harder the more you grow and the more to the right you move in your organization. And that's exactly the problem that DHI is trying to solve for you. We do all these things, if you want to advance one slide, Mike, with a very kind of like sophisticated process here. And a few people have asked about AI usage here. Why do you need all this when you can use AI? Well, at Docker, we employ AI at every stage here. It is a helping tool for all of our security engineers and engineers working on these products to actually ship these images. It's not enough to just try to use AI to productionize an image at the very end, because you also need to protect your build pipeline and your developer environment with thinking sandboxes and all this stuff. So it has to be used across the whole chain, and that's kind of what we're doing across this flow here, all the way starting on the left here, just really tracking whenever something changes upstream, making sure that we kick off the right builds here. How are we building? Well, we're building in a SALSA build level 3 compliant infrastructure. We make sure that all our inputs are pinned to a particular version, that they are declared upfront so that you don't end up with like surprises when you actually do your builds. We run in network isolation. We do malware and vulnerability scanning. We look at each and every CVE as we detect it. Can we fix it? Is it actually something that is exploitable in the context of our images? Or can we maybe provide a VEX statement for our customers? At the end of that half pipeline, we have effectively an image that we need to run through functional testing. So we're using things like container tests with test containers here to actually validate that these container images still work in the way that they're intended to work, despite all the hardening that we have applied. Hardening comes in like different flavors. We have different versions, variants, that's what we call them for runtime and development. The runtime variant has no shell, for example, no package manager. The development variant, on the flip side, has a package manager, has a shell, and so on and so forth. So you can really pick and choose which one of those flavors you want. And then as we move to the right, we're dealing with things like FIPS and stick and CIS validation for our customers. So each of those images will have a FIPS variant that is kind of like FIPS enabled so that you can just take this image and kind of take it into your organization and go seek a FedRAMP compliance audit or maybe a FIPS compliance audit with these images. And then something that I think Mike's going to touch on at the very end here, we also carry all of these benefits forward into something that we call our customization pipeline. So when you decide this image isn't what I need another dependency in my image, you can still benefit from this whole process by using a feature called customization in DHI. Now, what I'm really, really excited about, and I've spent more than 2 decades in this industry, is that we shortly before the holiday break in 2025, we effectively made Docker Hardened Images free for every developer, not just for every developer, but for every person on this planet to use in their organization and in their environment. So what you can do with this now is you can effectively take our images, the sources of these images, you can build them yourself, you can download them or pull them from our registry and use them to your heart's content. You can mirror them, you can customize them, you can build them, you can build your own applications on top of them, and kind of really start building secure applications from the foundation. We currently have about 1,000 plus hardened minimal images in our catalog. As Mike said, there are MCP servers in there, Helm charts. All of these images come with like all the great attestations that you need to kind of comply with audits and kind of like compliance frameworks. Like they all come with SBOMs that are needed for like, for example, CRA in Europe. They all come with like a SALSA build level attestation that you can use to verify all the origins of all the software components that we used to build and that ended up in the final artifact. And then all of these images come for Alpine and Debian. They come for ARM and AMD 64 platforms.
I think I'm gonna try to hand the sharing baton over to you to
Yeah, that's the part that I worry most about.
Let's see. Let's see if we can do it.
Yeah, let me see if I can share and then. That working, Mike? Can you see my screen?
Yes, sir.
Awesome. All right, let's what I want to do is just do a very high level overview over like what DHI is and how you can utilize this in your environment. So first of all, you kind of need to log in with your Docker Hub account. Once you've done that in your personal account or in your organizational account, you'll see a new menu item on the left, which is called Hardened Images. And when you click on that, you kind of are taken straight into the catalog. And this is kind of like the full collection of all the images that we have in our catalog. And we did mention like MCP. Everyone likes a good MCP server these days. So let's take a quick look. Of course, we have MCP servers here. We have a dozen or so of these MCP servers. There are descriptions on how you can use them. So for example, here's a little bit of a Claude Code snippet that you can use and kind of plug this into your Claude Code. And the good thing about this is it's actually in a container image that has 0 vulnerabilities. You can't really tell this because it's not showing any. Sorry. But this already shows you up top here that this GitHub MCP server has 0 CVEs, zero known CVEs at this point. It's really small compared to the upstream version that GitHub releases. So we are making every effort here to kind of build the best hardened MCP servers. But what I really want to show you is how can you make these images yours and kind of like use them in your applications. And for that, I want to jump into the node image and maybe take a quick look at all the different variants here so that you can already see like there's a lot more here. There are about 85 different versions of our node image, and they all come with like slightly different security footprints. They all are CIS compliant. There are FIPS and STIG compliant version. STIG here means that they are hardened following the conventions in the general purpose operating system SRG. You can already see something like how long are they supported. This little X means there's something like an enterprise, an ELS offering here where you can get extended lifecycle support. What I would really want to do is like maybe dive into one of these images and take a look into how I could use this in my application. So this is a very recent Node version in the development variant. I can take a look at all the packages that are included. Take a look at the vulnerabilities. Well, this is interesting. There are a couple on curl here right now for which we're waiting for kind of like upstream fixes. I think at this point the community is still trying to figure out how to address these things. So that's why you see them still here. They will go away in a few hours or tomorrow perhaps. And one really important thing is from a compliance perspective are all kind of like the attestations, right? Everyone provides images. You can pull images off of Docker Hub, but who guarantees that these images actually come from the source that you think they're coming from? How can you verify the build pipeline? What's in these images? How have they been tested? How have they been stick scanned and all this? And this is effectively kind of your way of doing this. All of these images are attached to the, all of those attestations are attached to the image. And at all times, you can pull them and then you can cryptographically verify them using the commands listed up here. So they're all signed with our signing key. Under the covers, we're using cosign, so we're not inventing our own signing solution here. This command is just kind of like a little wrapper around to make this easier. Then going through the list here, we have a bunch of attestations. Of course, there are SBOMs, Cyclone DX, and an SPDX SBOM. We have our SALSA provenance that is kind of collecting all the build materials that go into the build, like including compiler tool chains. So we are compiling Node from source here. Of course, you want to know what GCC compiler we used, and that's in the provenance attestation. There is a CVE scan attestation. We scan for viruses and malware. Here's our test attestation. So you can see exactly what tests we run on these images. Secret scan. There's a VEX attestation. Another interesting attestation. Sometimes these images contain copyleft licenses, and when you take them into your environment, you need to kind of reproduce, or we need to reproduce the sources so that you can see kind of what GPL changes what changes to GPL code did we apply. And that attestation is effectively a link to a source image, to a source table that has all the sources for you to kind of like download and look at. Change log, so what has changed between this image and the previous version? So really, really important to know this too. Enough talking, let's do some coding and then see if this goes as planned. So I want to start using this hardened image on my Docker file. So this is my current Docker file. It's using upstream node from Docker Hub, as probably everyone on this call has used in the past at least a couple of times in their life. And I now want to start over and start my journey towards DHI. And the way I usually do this is I just ask Docker AI to do this for me. And that is a very risky play now, because we all know with AI, the results are a little bit undeterministic, but I did this a couple of times and it actually gave me the results I wanted. So the first thing that this AI agent does as part of Docker AI as Ask Gordon is effectively it's going to read the Docker file, and it is then going to go and take a look at all the images. No, I don't want you to run the build. And then it comes back with suggestions for which tags to use and all of that stuff. So I can already see that it changed my node 25 to dhi.io. And this is the registry that you can pull these free DHI images from. So again, go ahead, do a Docker login against dhi.io, pull these images and start using them. And it actually picked a socket firewall version for me, which is interesting. Let's see what that does. And yeah, I did a couple of other changes, added a non-root user to my copy instruction, and so on and so forth. So let's take a quick look at this. Let's run this again. And we can see that it changed this here, and it changed this image, and it added this down here. So that's all great, right? Like that looks really good. But actually, you know what? I forgot something, and I should have done this before. We should go back and do a quick test on how our image actually looks like. So let's do a Docker build of the current application so that we know where we're starting from. I missed this. So let's take a quick look at this. So this is my current version that's running in production somewhere. Well, it's a sample app, but for the purpose of this demo, let's pretend this is running in production somewhere. And let's take a quick look at how many CVEs we got in this. Come on. This is the awkward moment. Mike, do you have a question for me while we wait for this?
What's your next bike ride going to be?
All right. All right. So well, I'll answer this in my next break then, while we wait for the next thing. So 182 vulnerabilities. This image is actually riddled with CVEs here: 6 high, 7 medium, 165 lows. Now, what I did before in preparation, I had this Dockerfile migration done before, just in case. So it's now called dhi.dockerfile. And I'm loading this into a different tag, the DHI tag. So I want to take a quick look at what happens now. And one thing you'll notice is Gordon had picked the socket variant here. Socket is a partner of ours, and it is blowing up. And this is the nice thing about just switching to DHI here. I immediately got something called the socket firewall, which is free, and that actually found a name squatting dependency that someone probably by accident put into this application. So this is actually malware that my previous build just happily installed. Well, let's fix this quickly. So when we go into our package.json, we see here the typo. Let's fix this, and yeah, this version is dodgy too. And when we go back, hopefully this is now working, and we can actually look at this image. See, here it says protected by socket firewall. So this is going to look at all my dependencies while we're installing this, and going to check them against known malware, known CVEs, and whatnot. So another level of protection, not just the base image is secure, but also when you are using this to install applications, it is trying to keep yours secure. This is now kind of like built, and I prepared something earlier, which is another scout command that we offer, which is comparing the new image that I've built against my previous version. And here in our summary, you can already see, like, not just fixed it a bunch of vulnerabilities here in total, like all of them are gone now. It also greatly removed the image size and the number of packages here. So you can kind of like see the reduction of kind of image size and all this. And this is all followed by a long list of like packages that got deinstalled, CVEs that got fixed just by switching out like 2 from lines and a copy command and whatnot. So really, really interesting. One of the things that, again, we spoke briefly about the open sourcing aspect. So this is the catalog. This is kind of like the beautiful face of DHI. You can kind of look at these images. You can see all the security metadata of these things. You can kind of pull them. You can verify them and all this stuff. But if you want to get your hands into the code and like really start to understand a little bit more of the inner workings of this, I encourage you to go into our Docker Hardened Images GitHub organization, and there's a repo called Catalog. There's also a discussion forum here, which is going to be important for a little later in this conversation here. I think Mike's going to have something to say about the discussion forum. the important aspect here is that you'll find chart images and packages, and these folders contain the image definitions. So when we go into, let's just pick a simple one. Uh, so for example, this is a file here that we use to produce our Alpine base image. And you can see kind of this is not really a Docker file, but I keep calling them Docker files because Docker files are not just the Docker file that we know. It's effectively everything that you can feed into Docker build. And the first line kind of determines what front-end build kit Docker build is using to interpret this file. And we've created our own version, our own Docker file front end here that interprets this YAML file and builds a Docker image from this. Now, this sounds all super complicated, and luckily we also made something available, which is kind of exactly this image here. With this information, you can now go into another shell here, and I'm just in a local clone of the catalog repo, and I can now do Docker build. If I could type, sorry. I could even just build the remote file here using Docker build. So this is a reference to the file that we looked at straight out of GitHub, right? You don't even have to do this locally. And what you end up with is effectively your own my Alpine base. So this is now in my local daemon. I've created my own version of the DHI. Now, sometimes this might not be enough. So you may want in your hardened version of Alpine base, which is this one here, you may want curl, and you maybe want the real CA certificates, not just the bundle. So just add curl here, go here, back onto your command line, and rerun. Oops, sorry. Ah, sorry. Don't trust your shell history. So this was me trying to run this build from the changed file now. So I passed the YAML file into Docker build. I tag my image now, and another typo here, 322. It should be 323, but let's roll with this for a second. And I can now do Docker run IT. And if this worked, keep my fingers crossed. Yes, there's curl. Curl wasn't there before. With this simple change, I added curl. And the important part of this is there is no APK here, right? There is no kind of like full-on Alpine version, but you installed curl nevertheless in a very easy kind of way to do this locally. This is still using the exact same Docker build that you all use already in your CI, on your laptop, in your Docker desktop. So there is no change required other than start using YAML instead of Dockerfile. I think that's it, Mike. Over to you.
That's amazing. I think it's amazing to see all that um, come together and work. The demo gods, I think, worked out in our favor. And you also used AI, which is always risky. Um, we've we're just super proud, excited that we're able to now set a new standard for the container ecosystem overall by making all this open source available for everybody to use. It really shouldn't be any sort of roadblocks between now improving and hardening your container workloads. Um, and then for the then there and then as you start to do that, as the industry starts to do this more and more, and we work with so many different customers and enterprises and businesses with this, we're there for you on that entire journey as your environments become more complex, as your compliance requirements become more complex, and just we're just here to see you through that entire journey. And this is where, in addition to having Docker Hardened Images just available open source for free to use, we do have an enterprise tier, and then as CD talked about a little bit, the ability to get extended life cycle support for those versions that go end of life. So in the as for those businesses with the needs around the enterprise features, This is where you're going to be able to get access to continuous patching, where we do that entire a lot of the process that CD talked about. We have an SLA for critical, a 7-day SLA for critical and high remediation, a 30-day for medium and low remediation as well. As you can imagine, right, getting to zero CVEs is, we always say this, it's a journey, not a destination. You're every day, every hour, there's a constant, different life cycle to vulnerability. So that continuous patching is very important for enterprises who need to run a vulnerability management process. And the enterprise is where you get access to the FIPS and STIG variants that we build for those seeking FedRAMP or other FIPS compliant frameworks. And then that entire process, of course, you can use the build service and the image definitions and start to run them yourselves. We also provide a full managed service for that customization experience as well, which I'll go into a little bit more. All that's available in the enterprise tier. And then as an addition to that, if for certain technologies, and I know no one ever really likes to admit they're running end-of-life software, but it just happens. We work at places, we have very complex environments that we all work at. For those who need a little more time to maybe do that upgrade, we're always going to be promoting that you use the latest and greatest versions, but we want to give you more control over that timeline of when you do those upgrades, because everybody's in a different situation. Environments are complex. This is where the extended lifecycle support comes in, to where if a version of the software goes end of life, we'll provide an extra 5 years of support for security patches that will follow through that same hardening technique and build process that CD just talked about. Kind of covered some of this stuff already. I'll go through and show you customizations real quick before we get over to Q&A. But it's also just important to recognize that, it's not only that continuous patching, but it's also like holding Docker accountable to the vulnerability remediations, the CVE fixes. This is really important. It's a big burden that a lot of enterprises and just engineering organizations face, is how do they remediate vulnerabilities, and how do they remove that burden so they can get back to what their core business is. Most companies, their core competency is not remediating vulnerabilities. It's doing innovation on behalf of your users, your customers. The enterprise tier is all about, having Docker fill that gap so that you can get back to innovation and not have to worry about the toil of vulnerability remediation. It's also important to maybe double click a little bit on what we mean by continuous patching. There's let me walk through this visual to describe what we mean by continuous patching and why it's important to have some kind of a hardened image program that you can rely on. At the top is a sort of a simple way, a standard way to think about the open source project release cycle for vulnerability security patches. It's actually pretty common for a CVE to be published along with an upstream patch being being completed or being like coded, right? Usually there's a vulnerability disclosure time period. You have 60 days before it goes public to make a fix. And so the upstream projects in the open source community are usually very good at responding to this, because everybody actually does care about security and vulnerabilities remediations. The issue comes in when you have to start now releasing that fix to those patches to the community, right? Every open source project is more or less on their own release cadence, release cycle. And that's really difficult for a business to understand and keep track of. And then those release cycles generally are not made to adhere to any sort of compliance guidelines, whether that be for any sort of vulnerability remediation program, whether that be SOC 2, whether that be all the way up to FedRAMP. And so it's the time it takes to actually get access to those security patches and release them. That's where Docker Hardened Images comes in. That's where the enterprise tier of Docker Hardened Images comes in. We're essentially through a ton of automation and a ton of and a fairly massively scaled event-driven build system, monitoring for not only vulnerabilities but also those upstream security patches to be accepted by the upstream project, and then we will do the backporting of the fix to essentially all the current versions that are being that are in the catalog, so that we shorten that release time, making that patch available to you within that SLA for CVE remediation. That's the time frame that we're really cutting down on, which can ultimately save days to even weeks of time before that security patch gets made available to you, along with all the other hardening things that we'll do as part of the build process. And then just another quick note on that extended lifecycle support. So this is, this is generally for those businesses who need an extra time in order to do their upgrades while still getting the security patches and still getting an SLA for vulnerability remediation. We want to give control back to those organizations to upgrade on their timeline, and that's why we're providing up to 5 years of support so that you have a lot of flexibility while still getting the same security outcomes that you get from using the sort of standard version, the supported versions. I'm going to go into this a little bit more. I think we have time to show real quick, but the experience that CD showed, where essentially updating our Docker file, the Docker file to add in some packages without actually adding in the package manager, that customization experience that you can do locally yourself, is also something we offer as essentially a managed service that's available in Docker Hub that we essentially manage the full life cycle of that image and run the builds for you, so that you don't have to build a whole new set of pipelines to do that yourself, or become experts in how to structure all these images. I'm going to show that real quick just so that you get a sense of it. Let me stop sharing and then pull over another screen real quick. See how fast I can do it. Great. Okay, so I'm over in just same kind of screens that CD showed over in Docker Hub. This is our sort of like demo business account that would be an enterprise customer. Um, you can see I have access to a couple other variants here because I'm in an enterprise account. You see the same socket firewall enterprise same socket firewall variants are there that really cool and really great to partner with them on that. You can see access to the FIPS variants, both dev and runtime variants, as well as this is got extended lifecycle support for Python that you get access to. But over in once you start actually mirroring and using our hardened images, you get access to our customization experience. I'm just going to pick an example here. I'm essentially mirroring all these different hardened images over to my organization. I have essentially a private copy that we're managing and pushing to you, so that you get those continuous patches. When I'll go into like a Tomcat example, right? Here you're able to now in this repo go to customizations and create as many of these as you'd like. What you're able to do with customizations, it's essentially a way to do everything that with CD, alter that image definition on top of the base image definition, and then we manage the rebuilding of that. So you're able to do a whole lot of interesting things here. I can do things like add additional packages, like that's essentially what CD showed, right? Adding curl, you get access to thousands of packages you can add in here. Part of our hardening process is very much to remove system packages that are not needed by most. But if you need to add in your own customize your own packages, that's the way to do that here. The other really powerful thing that we allow you to do is to add additional OCI artifacts on top of this image definition. It's essentially like merging multiple image layers together from different from different OCI artifacts. This allows you to do extremely simple things, but also extremely powerful things. This is how you can do things like make sure that your certificates are added to every image that you're getting from DHI, so that you don't have to do that on your own, and we'll manage the building of that. And it also allows you to do things that are even more complex, like merge multiple services together. Of course, we all know the best practice is to run, run one service per container, but the real world is different. Applications, architectures have evolved over time. We all carry baggage in our architectures. So this allows you to do things like have one image that's running three different services. You could have an image that's running Tomcat, Python, and Redis all in one image. And the goal there being not that it's a best practice we promote, but it's more about how do you seamlessly migrate from what you're currently doing, whatever your current architecture is, to something that's more secure and utilizing hardened images without having to go re-architect the system. We just find that if the burden of migration is too heavy, then there's a big delay and potentially no movement on securing that infrastructure more so. So we're trying to make it really easy. That's why we invest heavily in the Docker agent that CD showed to make it very easy to migrate to. It's also why we have this customization experience that's very flexible. You can also do things like add in sort of more standard Docker file things that you might recognize, like environment variables, users, tags, groups, entry points, all those types of things. You can configure that here, and this is not only available in a UI format but also a command line tool that is being made available, as well as we'll do more and more to make this something that you can codify. But then once is this customization is running, we're managing the entire life cycle of this customization, rebuilding these customized images based on CVEs, that the patches that are made available, new versions that come out. You don't have to do any of that in your own systems. We're managing that for you at scale, and then you get access to different, so you can see the builds, you can see what's happening with your images, you can get access to them just like you would anything else that comes out of your CI environment. Okay. Um, with that, I know we want to leave some time for questions. So I'm going to get through some of this. We definitely think about Docker hardened images as fitting seamlessly into your entire DevOps stack. We do this with a ton of partners. CD showed Scout as a scanner, but we work with all the scanners to make sure that these images give you the most accurate, the scanners give you the most accurate depiction of vulnerabilities, as well as making sure they work with a whole host of registries and other cloud technologies, other dev tools. We're very proud of our customers. We're very proud of the impact we're having in the industry in honestly such a short amount of time. I won't read these, but we're just very proud of the impact that Docker Hardened Images is having in the container ecosystem overall. And then the one of the other things that we're very focused on is we talk a lot about security theater here and how to not do that, how to do real security, and we want to always make sure that we are um, being validated by getting feedback and being validated by multiple parties. We've gotten external validation on all these claims that we talked about, all the things we've been showing by SR Labs and we'll do this multiple times continuously. We're very much focused on making sure that this is the most secure and hardened solution for you to base your applications on top of. Okay, I'm gonna get to questions soon. With 10 minutes to go. Before I do, I just want to leave you with some fun stuff that you can go do right now. We show, Docker hardened images they're free, they're open source. You can go use them right now. We're looking for as many projects to start using Docker hardened images today as possible. We've already had over hundreds of applications start to migrate to Docker hardened images. Really exciting to start engaging with the community. We want all of you to go off and start building and migrating your own open source applications to use DHI. We want to hear about the experience. We want to see it in action. So when you do go to that discussion, go to our open source project that CD showed. You can use that link in the slide as well. Post a discussion in the show and tell forum with a link to your project in it, and then you'll the first there's a limited supply of this, but the first 10 to 20 different projects that do this will ship out some fun custom swag, a really fun Lego set, and a cool sweatshirt. And then for those who are looking to explore the full feature set of Docker Hardened Images in the enterprise tier, you can start a free trial today. Just go to that link and yeah, start building. Um, you can get in touch with us in many ways. We're everywhere. We're everywhere on. We have our Slack community. We have our support channels. We have our GitHub projects. Um, we're always at conferences. We're always everywhere. Always loving to talk to everybody about and feedback and how we can make the Docker ecosystem better overall. With that, I think I'm done blabbering. We should maybe go to questions. And so let me try to pull these up. I don't know, CD, have you been able to monitor questions a little bit?
Yeah, yeah.
Let's see,
I
most
think
upvotes. Should we do that? Should we look at most upvotes?
yeah. Well, I mean, one of the theme. Well, that's unfortunately it's not even sorted by most upwards, so you kind of need to go through the list.
Oh, you can rank it. So like I see that
Oh yeah.
there's 9 for
See.
how can we leverage the free version of DHI image to do some research and see if it fits government requirement. Yeah, you can use DHI images now. They are free. They're Apache 2.0 license. So now you and available on Docker Hub for free. Um, you are able to do that. So you can just start leveraging them now. Um, some other ones. Okay,
Yeah.
questions about.
Well,
Go ahead.
one of the I think one of the recurring theme here is around like um ties from DHI to kind of core Docker business and team. Maybe you want to say a few words about that. Like, do you have to be a Docker business customer to get DHI?
Oh no, no, no. Yeah, you can you don't have to pay for anything to do that. I mean, so Docker team, Docker business, we have there's certain like offerings that we have out in the market, and you can get access to them through our Docker business license or our Docker team license or a Docker Pro license. You don't need to have any of that to access hardened images. This is very similar to Docker official images for those who are familiar and use those, right? Those are just available on Hub and able to be pulled, and you don't have to. We're here to make that available. We're here to set a new standard for the ecosystem. In order to do that, uh, that has to be they have to be made freely available. Um, there's one question in here, CD, about somebody's approach at mitigating a vulnerability. I wonder if I'm reading this.
Yeah, no,
Um,
I'm reading this and I'm trying to kind of come up with an answer. I think this is technically possible to kind of like remove the thing at the
After
very
it's
end of
built,
your build
is that what?
pipeline.
Yeah.
Um, and that will in most cases quite make the scanners quiet, right? Like it will kind of remove the vulnerability from being flagged up. But the thing that I would I want to caution everyone about is like this component is still around when you're kind of like assembling your image. So like if you're running, for example, a compilation in this image or a test suite from someone else, you're always potentially exploitable at that point because this component might still be in there. So you have to be very clever in in the way in order in which you orchestrate the deletions and the builds and whatnot. In general, I would recommend trying to start with something that does have as minimal components as possible and then start adding these things in. And I think DHI is kind of like a way of doing this where we could start with one of our images that does not have zlib in it. And then if you don't need it, you don't have to remove it at the end of the day.
Yeah, I think it's more scale. I was thinking of it like a more scalable and maintainable solution to go from scratch up, basically. I see, can we deploy DHI via the Docker MCP gateway? We do the Docker MCP gateway. You can utilize our Docker. You can basically do everything CD just showed using Docker AI to help you migrate your applications that might be using a non-DHI image to use a DHI image if that's what that means. And then you can, of course, use your agent and other helpful MCP servers that are available in our cataloging tool in our gateway to actually run a deployment for you into like whatever your target that you want, whatever target environment you want. It's actually
Mike, another one of your favorite types of questions is in terms of distributions. Right now, it's Alpine Debian. What do we have planned for the future, if anything?
Oh yeah. I do love this question. So yeah, our goal is to have to create one of the North Stars of this whole product is to make it very seamless to migrate to. And the fact that we support multiple distros is a key way that comes to life. So we're going to be adding more and more distros over time that we're compatible with, as long as we can, staying adhering to licensing and IP restrictions and all that stuff. Rocky Linux, Alma Linux, some kind of RPM compatible distro is definitely something on our roadmap. We would love, please submit GitHub issues or discussions around this. We would love feedback from the community of what they would be looking for, because this is definitely something that we have on our roadmap that we want to build towards. I see a question about Iron Bank. We don't currently. Um, these aren't currently listed on Iron Bank. At least not to my knowledge. Like we don't do anything to make that happen. We're in talks with folks from Iron Bank to figure out how we can do this together. But it's not currently available on Iron Bank. You just go to Docker Hub and pull from Iron Bank, or sorry, pull Docker Hard images.
Yeah, another couple of questions around partnership here. Like, how do you get your images into the catalog? I think that's a good question. What I would recommend here is reach out to either Mike or myself, and we put you in touch with our partner team. And like these guys are really good at like establishing a partnership and figuring out how we can put content into the catalog.
Yeah. And we've also started to feel free to submit image definitions to the open source project, and we can. That's another great way to get started too, with getting if it's a particular image that you'd like to see. I see one about the about our hardening process here. What does DHI do in terms of going distroless? I think we kind of talked about it. I don't know if CD, you want to say anything more about the hardening process there?
Yeah, so I think we would definitely qualify for like the distroless moniker tagline. Like we have a bunch of images again that don't have a shell, that don't have a package manager, that come with like the minimal footprint that is required to run the application that it is kind of like packaging up. And I think the question mentions Nginx. A couple of variants need kind of, for example, a shell to do like environment substitutions and config files. So there are various variants that we support for Nginx, and they go from like literally only Nginx plus like the runtime dependencies, probably libc and a bunch of other things, towards like one with a shell, and then maybe one even like a compatibility, a variant that is kind of like very compatible drop-in replacement to upstream images that you can get from other places. So yeah, I would definitely say this like DHI images very specifically in the runtime variant are distroless.
I think we should call it. It's the full hour, top of the hour. Really appreciate everybody joining. There's a lot of questions that we're going to figure out how to follow up with and answer. And remember, we have our Slack. You can ask them again on Slack. You can ask them in the GitHub issues and reach out to support or as CD said, just reach out to he or I, and we'll respond to them. Again,
Yeah, I think the GitHub call out is really important. Like, in fact, there was a question in one of that I closed earlier around discussions from someone who raised a lot of feedback there. Go do that. That's very valuable, right? You can interact with the team directly. That's very it's very kind of like productive for us as well.
yeah, it's a great call out. Okay, well, thank you everybody. Recording will be shared out. Looking forward to seeing you around. Bye bye.
Bye. Thanks, everyone.